Imagine this. You're walking down the street, sipping your morning coffee, just enjoying a completely normal day. Suddenly, in a literal microsecond, the entire world just stops. And I don't mean the cars or the people or the air. I mean the actual solid ground beneath your feet. You get zero warning. In less than a single second, humanity faces an apocalyptic event way beyond our wildest nightmares. So in this explainer, we're diving deep into the terrifying reality of what actually happens when the world just stands still.
It's kind of the ultimate doomsday what-if question, right? What if the Earth stops spinning for exactly 60 seconds? Now, you might think a 1-minute pause sounds, well, relatively harmless. I mean, what's 60 seconds to a planet that's 4.5 billion years old? But the physics behind this brief little pause, it would completely rewrite the face of our planet forever. So we're about to start a 60-second countdown on the ultimate survival thriller. Let's get into it.
To really wrap our heads around the nightmare of that very first microsecond, we first have to talk about speed. Because right now, as you sit there watching this explainer, you are actually hurtling through space. We just don't feel it. Everything around us, the buildings, the oceans, the atmosphere itself, we're all just moving together in this perfect, constant harmony. But if the ground suddenly hits the brakes, that peaceful reality shatters instantly. Depending on exactly where you live, the Earth is rotating at absolutely incredible speeds. If you're standing near the equator right now, you are moving east at over 1,670 kilometers per hour. That is over 1,000 miles per hour. And even if you're further north or south, you're still moving at hundreds of miles per hour. This constant, invisible momentum is basically the foundation of our entire existence, and, unfortunately, it completely sets the stage for our 60-second disaster.
Which brings us to Section 1, the microsecond it stops.
So, the big player here is Newton's first law of motion, good old inertia. An object in motion stays in motion, right? When the solid Earth abruptly stops, absolutely nothing on its surface has a reason to stop with it. You, your house, your car, the trees, everything would just instantly keep traveling east at that original blistering speed. Think about being in a car going 100 miles an hour and slamming into a concrete wall. Now imagine that wall is invisible, and you are traveling literally 10 times faster.
To put this horror into perspective, astrophysicist Neil deGrasse Tyson totally hit the nail on the head. He pointed out that in a place like New York, you're moving at about 800 miles an hour. If the Earth stopped, he says, it would be disastrous. If you weren't seatbelt buckled to the Earth, you would fall over and roll 800 miles an hour due east. It would kill everyone. Yeah, millions of people and unsecured objects would instantly just become supersonic projectiles launched horizontally into the air.
Next up, Section 2, supersonic winds unleashed. Okay, even if you were somehow anchored to the ground, the atmosphere itself keeps moving. To grasp the sheer scale of this, think about the absolute strongest Category 5 hurricanes ever recorded. Their winds top out around 408 kilometers per hour. But the inertia-driven winds from the Earth stopping, they'd reach 1,670 kilometers per hour at the equator. That is more than 4 times stronger than any storm in recorded human history. These supersonic winds would literally just scour the surface of the continents clean in a matter of seconds. We're talking forests ripped up, mountainsides flattened, and entire concrete cities reduced to dust.
Moving on to Section 3, oceans reshape the world.
So while the winds are tearing up the land, the water is triggering an even bigger nightmare. It all comes down to centrifugal force. Basically, over billions of years, the Earth's spinning has pushed ocean water toward the middle of the planet. Right now, as we speak, this force maintains a massive 8-kilometer-high bulge of water right around the equator. Our coastlines, as we know them, exist entirely because of this super delicate balance between gravity pulling the water down and centrifugal force throwing it outward.
But what happens when that balance certainly breaks? Well, step 1, the rotation halts. Step 2, that outward centrifugal force instantly vanishes. Step 3, gravity becomes the absolute boss. It violently pulls billions of tons of water from that 8-kilometer equatorial bulge straight toward the North and South poles, because gravity is actually slightly stronger there. And step 4, multi-kilometer-high mega-tsunamis sweeping inland. Walls of water so huge they wouldn't just flood coastal cities, they would swallow entire nations whole in minutes.
As all that water settles, the entire map of the Earth gets rewritten. Because the oceans rush away from the equator and head for the poles, we end up with one giant equatorial megacontinent wrapping right around the middle of the globe. And those vast, low-lying northern territories? Say goodbye to almost all of Canada, Europe, and Siberia. They disappear completely beneath a massive new northern polar ocean, and the South would see the exact same thing. Crazy enough,
The highest point on this new global dividing line wouldn't even be Mount Everest. It would actually be a peak in the Colombian Andes.
Section 4. Earth's core and crust react.
Now getting closer to that 60-second mark, let's look below the surface. Because the Earth spins, it kind of bulges out. It's actually about 42 kilometers wider at the equator than at the poles. It's a flattened ellipsoid. But without that rotation, gravity aggressively forces the planet into a perfect sphere. This violent reshaping would literally tear the Earth's crust apart. We'd see impossible magnitude 10+ earthquakes and simultaneous volcanic eruptions all over the globe. And worse, the liquid iron core would stop swirling, which kills our magnetic dynamo. Without that, our magnetic field vanishes, completely exposing the Earth to deadly solar winds and cosmic radiation.
And finally, Section 5, the devastating restart.
You see, if stopping was a total catastrophe, restarting is the final nail in the coffin. Second 60 arrives, and we get this horrific double-tap effect. The Earth suddenly jolts right back into its 1,000-mile-per-hour spin. This generates a massive reverse shockwave across the planet's mantle, instantly shattering whatever tiny fragments of the crust somehow survived the first 59 seconds. Plus, all that water, wind, and debris that was rushing toward the poles, it would all violently surge back in the exact opposite direction in these chaotic, crushing currents.
Okay, before you start digging an anti-inertia bunker in your backyard, let's take a deep breath. A sudden stop like this is physically impossible. There is literally no force in the known universe capable of instantly hitting the brakes on a planet that weighs 6 septillion kilograms. But here's a fun fact. Something called tidal braking is completely real. Thanks to the gravitational pull of our moon causing friction in our oceans, the Earth's rotation actually is slowing down as we speak. The good news, it's only slowing down by a microscopic 2.3 milliseconds per century. So it's a super gradual shift over billions of years, which gives life plenty of time to adapt instead of being wiped out in 60 seconds flat.
It is absolutely wild to think about, isn't it? Our entire existence, our safety, our beautifully stable coastlines, it all relies on this massive rock spinning thousands of miles an hour right beneath our feet without us ever feeling a thing. So now that you know just how perfectly balanced our world actually is, I have to ask, which scientific doomsday scenario should we explore next? Let me know down in the comments. If you enjoyed this explainer, be sure to leave a like and subscribe for more deep dives. Thanks so much for joining me, and as always, stay curious.